Good morning. Hi. Welcome to Tuesday of Build, and welcome to our talk on WSL. Yay! Come on, a little energy. Thank you. So I'm sure you've heard the news about WSL2, about the awesome file system performance, improved and full system call compatibility, as well as some other details. And so we're really, really happy to be showing you all of those details inside of our talk today, and as well some more information that you haven't heard before that we'll be going over today. So my name is Craig Lowen. I'm a program manager working on the Windows subsystem for Linux, and I'm joined today by...
I'm Ben Hillis. I'm the lead dev for Windows subsystem for Linux. I've been working on it for about 6 years, and just really excited to share the future with you guys.
Right. So let's dive in. That is the name of the talk. And this is the agenda thrown up for what we're doing today. But at the end of our 60 minutes, we want you to come away from this session understanding what WSL2 is, how it works, why we made some of the changes we made, what are the differences between WSL1, WSL2, and then our goals for WSL in the future, so our future roadmap. And it's also going to be chock full of demos, so you're definitely going to be seeing WSL2 in action, us using it, and what you can expect when you are able to start using it very soon. So before we jump in, let's situate ourselves in WSL. Is there anyone who hasn't used WSL recently, or has used it before and then is trying to jump back in? Awesome. Okay, I see some hands. So WSL is awesome. It's great. That's why you're here to talk about it, because it's great. And why it's great is because it allows you to run unmodified L64 Linux binaries on Windows. So that's the boring technical version of why it's great. And the real reason of why it's great is because if you're somebody who uses Windows, it opens the whole wide world of Linux to you on your machine in a really easy way. You can pull up a bash shell and get started working right away. You don't have to worry about dual booting or context switching. Everything on your machine is available to you for you to use, whether you're using a Linux or a Windows environment. And on the other side of that, if you're somebody who loves Linux, then WSL is an awesome opportunity to use Linux on a Windows machine. So you can use your favorite Windows tools, like maybe an app that you prefer to run on Windows, like Photoshop for the front end, while still retaining access to your favorite Linux tools. Perhaps you want to be a full-stack developer and do Node.js work on the back end of your website in a Linux environment. WSL is a really compelling solution for developers who want to work in a Linux environment as well as in a Windows environment. And we can't talk about WSL without talking about the amazing community that we have. So we want to say thank you for showing up today. I'd like to give a quick round of applause for everyone. Thank you for coming. And really, thank you for being so engaged with us on the team and with everybody in the community. This is a community that's active on GitHub, on Twitter, on user voice, on Reddit, and more. And it is an incredibly powerful community because every issue that you filed, every tweet that you've tweeted has helped make WSL what it is today. So I wanted to jump into some of those numbers. So we have 4,000 total issues. So don't worry, those aren't active. Those are just total.
We fixed some of them.
And we have, in total, in all of those issues, 32,000 comments. And if you counted all the characters in those issues and in those comments, that's 13 million individual characters. To put that in perspective, that is 2.5 times the length of the Harry Potter series to sit down and read our issues page. And if you wanted to read a much better series, it's 1.5 times the Game of Thrones series.
No spoilers, Craig.
Yeah, no spoilers. And what do we talk about inside of WSL? What do we ask, and what are our big issues? And those top customer asks that we've heard from the community is file system performance and compatibility. It's when can this run faster, and when can it run X, Y, or Z app, or Z app.
I'll let you have that one.
And those are our top asks, and we're really happy to say that WSL2 is our solution for it. And so we're really excited to be introducing WSL2 to you today. So we didn't just take the Windows subsystem for Linux and toss the number 2 on the end and call it a day, there's some significant changes made. So Ben, what exactly did we change when we did WSL2?
Right. So WSL is the platform. It's an easy way to run your Linux applications on Windows. And you can think of WSL2 as the same, the way you interact with it will be the same. You don't have to learn a new install mechanism. If you're using it today, it will feel totally seamless, but we've swapped out the back end to take advantage of improved file system performance, improved compatibility, and just made it a really slick experience for the user. Yeah.
Right. So on the screen, you can see that we have all the Linux distributions that connect to the Windows subsystem for Linux in the form of system calls. We just changed how we handle those system calls at the end of the day. So our goal is for WSL2 to feel the same as WSL1. Obviously, because we changed the architecture pretty significantly, we need to differentiate between these. So that's why it's called WSL2. And we're going to call the current version of WSL1. But at the end of the day, it's still WSL. That's the goal. So let's jump into some of the awesome improvements that you'll see once you start using this. The first is file system performance. How much faster is WSL2? So we did some speed comparisons, so we can jump over to my laptop, demos, and
I'll switch the input.
These actual numbers, oh, wait one sec.
Oh, yeah.
So these actual numbers were run on the demo laptop that I have here. They're just the exact numbers that I did. I did git clone of the VS Code repo, npm install of a personal project, and I did cmake on the OpenCV repository. And this is how much faster WSL2 was compared to WSL1. And so obviously, your mileage may vary. It depends on how intensive of a disk operation, whatever application you're running is. But these are significant improvements that you'll notice. So we can switch over.
Yep.
And the best way to show this is by running it at live, of course. So we'll open up WSL2. It's the exact same experience. I'll open up Ubuntu. And I've color-coded these just so to make it really obvious on which one's which. And let's make that extra obvious. So that's WSL2. And I have a npm package in both of these folders. And this is just an offline version of an npm package so that we're not getting hit by conference Wi-Fi to affect the results.
Don't use Wi-Fi in your demos, please.
No. So we'll start this one off with WSL1. And it's going to take a little bit longer than WSL2.
So we'll give it a head start.
Yeah, oh yeah. We'll let it go first. And we'll start WSL2 at the same time. And WSL2 is going to be basically a lot faster. So there, it's already finished before WSL1 does.
So that time it was about 3x or so?
Yeah, so there we go, 3 times. So that was 4 seconds in WSL2 and 14 seconds in WSL1. That's significant. That's noticeable. And the really amazing part of this, I'm going to close WSL1 now and go full screen to WSL2, is this is not just a change that is npm install or git clone. This is anytime you're accessing Linux files with Linux applications. So what's the first thing you do when you open up a repository? You do sudo apt update and sudo apt install. And so we can do sudo apt install fortune and cowsay.
Very important tools.
Yeah, what every developer needs. And this experience is also significantly faster. So it's already done installing that package, and now we can run our important applications inside WSL2. And so this is an overall holistic experience that you're sure to notice but between using WSL1 and WSL2.
Right. Ready to go back?
Yeah.
Cool.
OK. And if that was it, if we just shipped the ability to have way faster file system performance, we'd come up here and celebrate that. That's awesome. But the great thing about WSL2 is it's not just file system performance. It has full system call compatibility. And if that sentence does not make you want to go, yes, can I please use this right now? We can explain why in a quick story. So this is a real GitHub issue that we have on the Microsoft/WSL GitHub page. It's issue number 3031. And it matters because a user is asking about a ptrace system call, and it doesn't work in WSL1. And this matters because...
Yeah, so this is used by the RR debugger. It's, this person wants to use WSL to develop their project, and they want to debug it. It's pretty important ability to be able to have when you're developing code.
Right. And so the great thing about the dev being on the stage is that we can blame them directly for not fixing this.
Yeah, my bad.
And we can take a look at this issue, and it's something that has been open for a little while.
Right.
And this user is awesome, and they have posted their source code.
Yeah.
And
yeah, so they noticed our R didn't work, and then they really dug into it and found out, oh, this is where things are going wrong.
Right.
This is like if you can file a GitHub issue like this, it will make your devs' life so much better. It's just great.
So the awesome part is we've taken the source code, and we are going to run it in WSL1, and we'll check to see if it works. And then we can show how you can move a distribution from being backed by WSL1 to being backed by WSL2 and fix this issue for this user. So we'll jump back over. So I'm here in command prompt, and I'm going to just check out my distributions. So you can see I have a mix of distributions that are running WSL1 and WSL2, Ubuntu, Fedora, Alpine, Penguin. The Penguin team is also in the audience today, so if you have any questions for them,
Yeah, thanks for joining us.
show them after. And we have distributions that can run side by side. So I can choose whether I want to use a distro as a WSL1 distro or as a WSL2 distro. And we're going to jump into Alpine. And I have that piece of code that user wrote right here. Right. And we're going to just compile it right here with GCC. And we're going to run that. And it says ptrace failed, invalid argument.
Yeah, just like he said.
Too bad. So what we can do is do the command WSL --set -version. You type in your distro name, and you set it to version 2. And from here, it's going to start converting. So it's now converting this distro from a WSL1 to a WSL2 distro. Conversion's complete. We'll jump back into this distribution, and we have the exact same Linux binary that we compiled last time. And when we run it, a.out, ptrace succeeded.
Should we mark that issue fixed now?
Yeah, that'd be great. And so this is awesome because we fixed this issue for this user. But this is not just a fix for ptrace. This is a fix for a bunch of different system calls. And so there's tons of system calls that we need to implement in WSL1. And this is a fix for those system calls. And this opens some really awesome possibilities, like Docker, for example. So we can come back over. And I'm back in WSL2 on my Ubuntu distro. And we can go and start our Docker service. And so now we have Docker started. And we can check out what images we have. And we can run one. So I can run my Alpine image directly inside of WSL2, which is awesome. So you can start using the Linux environment version of Docker. This is something that we're also working with the Docker team on Docker for Windows to make this a really great experience as well in general for Docker users.
Yeah. Thanks. Thank you.
OK, so we've shown you the awesome parts of WSL2 and how it works, and really quickly an overview of the benefits of it. And your question now should be, but how? How is this possible? What did we do?
Magic.
Right, exactly. And so the best person to answer that is Ben. So Ben, can you help explain what changes we made?
Sure, thanks, Craig. So I think those demos are a really good opportunity for us to show you why you should be excited about this technology. But I think it's really important for you to know how it works, right? So before we can talk about WSL2, let's give an overview of WSL1, how it worked, and maybe some of the pitfalls there. So when you look at WSL, there is the Linux user space. This is your distribution. You acquire this from the store. The Canonical or Penguin or SUSE. These are a bunch of the choices of distributions we have on the Microsoft Store. This is the Linux user space. And we do not ship this. This is not shipped by Microsoft. This is shipped by our partners. So that part, WSL1 and 2, it's exactly the same. Then there is this translation layer. This is implemented as a driver. This driver is a Windows driver, implements the Linux kernel ABI. What that means is it implements the system calls, virtual files, file systems, basically the things that Linux user space need to run. And then on the bottom of that, we have the Windows NT kernel. So the goal of this translation layer is to take a Linux system call, switch, munge things around so Windows can understand what is trying to be done, and then call Windows for the underlying, file system, network, whatever system call you're trying to do. So walk you through an example of what that looks like. Open is a very common, very simple system call. It's for opening or creating files on Linux. So Linux user space will call the open system call. Our translation layer traps that. We see the file's path. We see some flags. We translate that into what NT will understand. Switch the path around, do the correct things for the Linux flags that are being passed in. Pass that down to the Windows kernel. Windows will open the file or fail if the file's not there. Return a handle back to the translation layer, and then we wrap that in a file descriptor, which is the Linux way of interacting with files. So the Linux user space doesn't know that this has happened. They think that they're calling the Linux kernel, and everything carries on like that. So it's pretty cool technology. Like we're really proud of it. It's been a lot of really great work. But it's not to say there aren't some downsides of this approach. So Linux is a very rapidly evolving platform, right? Like it's not static. They're adding new, really compelling features each, at a really rapid pace. And our translation layer is written by us. Like we have to implement this. We don't use the Linux source. We have to write these things, by hand by ourselves. And that introduces a delay between when, Linux kernel version 4.21 comes out with feature X. We need to now implement this and then, make sure that it's working and then ship it with Windows. So this creates a delay that we have to pass on to our users, and then you can't use the latest, greatest Linux functionality. So that's a problem. Another issue is that Windows is very powerful and flexible operating system, but there's some fundamental differences between the Linux world and the Windows world that make some of this translation slow, or at the worst case, like impossible, or very difficult without breaking app compat. So for example, the file systems are very different. The way file systems are handled are very different. The permission model is completely different. The memory manager has a lot of different semantics on one and the other. So these issues are, when we have to go from one mode to the other, kind of the best case scenario is it works just, you pass it along and everything works fine. If that's not an option, you have to implement it yourself, and that can cause slowdown. And then the worst case scenario is that the translation really isn't possible because NT just doesn't allow things, doesn't allow a certain operation. So I'll give you an example of that. So renaming a directory when you have a handle to a file open inside of it, right? So on Windows, what this looks like is you have a folder, you have a file inside the folder, you open it. So this is return. You now hold a handle to this file. You then call the move file API. This is all in Win32. And then you are trying to rename the directory to a new name. This will fail. You'll get error access denied. And that's, this isn't necessarily wrong. It's just the way that Windows decided to do this. But on Linux, if you look at the very similar code, you open a file, you get a file descriptor, you call rename, and that just succeeds. The file descriptor stays open. You're able to keep using it, but kind of the world underneath that file has changed. And like I said, it's not necessarily wrong or right, but it's different. And if we were to change Windows to adopt these semantics, we have 20, 30 years of app compat to consider, and we could definitely break things if we were to start allowing this. So that's a problem.
That would be bad.
That would probably be bad.
You don't want to break things.
Certainly not. So we've kind of talked about, what is it, like WSL2 is going to make everything, it's going to make my life better, but how, right? So the way that we're able to get this improved file system perf and get perfect compat, a lot of you have probably guessed we're using virtualization, right? But this is not the virtualization that you are probably thinking of when you think of VMs in the traditional sense. So we are using the latest, greatest Hyper-V virtualization stack, and we are using a real Linux kernel built from the Linux kernel source, and shipped as part of Windows. So let's talk about the kernel piece first, because I think that's really interesting. So right now it's based on 4.19. As the Linux kernel releases new stable versions, it's our plan to rebase that kernel image and give you the latest, greatest as fast as we can. This kernel has been specifically tuned for WSL2. That means that we have made some changes to make it boot very quickly. We've made changes to remove things that we don't need to run in our virtualization stack. So basically, this is custom tailored to run our workflow. It's fully managed by Microsoft. That means we are going to monitor for CVEs. We will service it. It will be kept up to date, kept secure. You don't have to worry about it. It'll be serviced via Windows Update. So that's kind of neat. So the Linux kernel will be serviced via Windows Update. There you go. Okay. So it's also open source. So we're in the process of making a repo that we build this kernel from open source. And you'll be able to see the tweaks that we've made to the kernel config, some of the changes that we've made. Our plan is to make all of this available upstream to Linux. Anybody who contributes to open source knows that there's sometimes some trouble getting things upstream. So we're working on, any changes we make, we want to make available to everybody. So that's basically what that is. So anyway, I think this is a really interesting time in the world and in Microsoft in general that, if you would have told me this 5 years ago, I would have never, ever, I would not believed this at all. But it's true. You can see it. So anyway, I talked about virtualization. And when you think of a VM, you probably think of a traditional VM, right? So you go through a boot. It's probably like a remote desktop type experience. It's very isolated from the host. So WSL is not that kind of VM. We use, I mentioned this great virtualization technology that has been developed for Windows Server and Windows Azure and is starting to be used for lots of interesting client scenarios as well. So since we use the Linux kernel, that affords us some other really cool abilities as well. So system calls are just kind of one piece of the puzzle. There's other things that the WSL1 don't support that we just kind of get for free with using the real kernel. 32-bit on an x64 support, like that, it just works, right? Because the Linux kernel supports that. Fuse, lots of these higher level asks. If you go through our user voice, a lot of these requests are now, that you can put a big checkbox next to them because the Linux kernel supports it, so we support it. We're able to use the ext4 as the root file system and to get native Linux perf for the file system. When you saw Craig switching back and forth to WSL1 and 2, that's what was happening. Is we were moving your Linux file system onto an ext4 volume or DHD. And then so the other really cool thing about using virtualization is that it's an area that Microsoft's really heavily investing in, and as it gets better, WSL will get better and better. So let's talk about, I talked about virtualization, I talked about how this isn't a traditional VM. What kind of VM is it, right? So we call this a lightweight utility VM or a single purpose VM. We have lots of kind of names for it. I'll refer to it as a lightweight utility VM for this talk. Originally developed for server scenarios. So it's in server and in the cloud. It's very important to be able to run a lot of workloads on one host, right? And there's a few options for that. You can have containers which don't have as much isolation. You can have VMs that have a lot of isolation, but you can't run as many of them. A lightweight utility VM is kind of a sweet spot between. You have full isolation from it being virtualized, but you can run a lot more of them because it doesn't have the same footprint as a traditional VM. So this is great. This is great for customers of our server technology because we're able to pass the savings on to you, and your bill is cheaper because it costs us less money to run your workflow. So that's great. These also boot very quickly. Craig launched WSL, and did you notice like a boot or like any kind of slowdown? It's about a second. So I'll have a demo in a couple minutes to show you how quick the boot actually is. It's really incredible. We're able to achieve that by directly loading the Linux kernel into the VM's address. We don't go through EFI. We don't go through a bootloader. So we're able to just load and set up some state that the kernel expects. It's pretty neat work. And then also, so I mentioned some other client applications of virtualization. WDAG, Windows Defender Application Guard, Windows Sandbox. These are available on client SKUs, but they use the same underlying lightweight VM technology. So this is a path that Microsoft is kind of going all in on virtualization being a really cool ability to expose functionality to you as clients. So kind of a side-by-side of what a VM, traditional VM is and what WSL2 is. So traditional VM is by design isolated from the host. WSL2 is not. We make a lot of efforts to make the integration really tight. With WSL1, it's like you're on the same machine. We want that to be true for WSL2. Traditional VMs boot fairly slowly, tens of seconds. WSL2 is under a second, about a second. Depends on your machine, of course. Traditional VMs take a lot of memory. WSL2 VMs take much smaller amount and only use what is needed. And then also, if you were to use a traditional VM for Linux development, that's definitely an option, but it's something that you're going to have to manage. You won't have the tight integration that's built in with WSL, and that you'll have to use SMB or use some kind of other tool to get some of these pieces of integration. And there might be others like interop, being able to launch Windows processes that it'll basically won't be able to do. And then WSL2, we take care of launching this thing only when you need it. So it's not always running on your machine. It only runs when you're running Linux apps. So let's go to a demo. I'll show you how quickly this is able to boot. Some of the kind of cool characteristics of it. All right, cool. So we have, let's get up Task Manager. And we have a lovely white command prompt. I'm more of a dark mode fan myself, but we can't all win. So yeah, go ahead.
What's awesome about this is you don't really have to think about it.
Right.
As Ben's showing you. So we're going to jump into some dialogue options that you won't really use.
So as a WSL user, you won't have to do this. This is just me showing you that this isn't magic. This is actually, this VM is not just running in the background and I'm lying to you. I'm going to show you that this is real. So HCS diag is a tool to see containers, VMs running on your machine. I'm going to do a list. And we have this GUID is probably Windows Sandbox or something. And then we have this WSL lightweight VM. So it's running right now, probably because Ubuntu is running. Let's tear the rug out from under it and get rid of it. So anyway, so it's gone. I'll list again. Cool. So we can just see there's that, the Windows Sandbox VM is the only one left. All right, great. So let's boot. Make sure we're launching a WSL2 distro. Alpine is still WSL2. That's great. So I have Task Manager up. Let's go to memory. So we're at about 5.4 gigs of use. We'll launch WSL2, launch Alpine. OK, that was quick. That was probably, let's see. So dmessage is a really good tool for Linux to see what's going on with the kernel. And OK, cool. We attached a drive at about 0.4 of a second. And then networking was fully up about a second later. And pretty instantaneous, really. And honestly, not much slower than WSL1. And then if you look at memory, thank you. If you look at memory, we went up maybe 500 meg. And then, like I said, that's how much this machine is using. If we look at top or something, we can see so we've got, anyway. So that's what that's using. Cool.
And this is something that right now it's only using 500 megabytes of memory, but it will expand and decrease as you use Linux applications. Right. The point is, ultimately from this demo, is you don't have to worry about it. Right. We're using this on the back end, but it's totally handled by the WSL architecture. For sure. And it's not something that you need to think about. And it's not something that when we showed using WSL before, we never had to interact with the VM, use anything about it. It's just totally behind the scenes.
You just launched WSL the same way you always have. You click the tile, run WSL.exe, and that's how you do it. Was there anything else we wanted to show in this one?
No,
I think that's good. Cool. So back to the slides. So I'll share a diagram. So WSL2, give you guys an architecture diagram of that. This will look familiar to anybody who's seen like a VM architecture diagram. You have Windows user mode. You have the Windows NT kernel. And the Windows hypervisor is what's called a level 1 hypervisor, so even the host is running on top of this hypervisor. And so these system calls are going through the hypervisor before they get to actual hardware. When you run a VM, it runs this virtual machine, runs the user mode, runs the kernel, and then it goes through the same hypervisor layer. So this should look pretty familiar if you're familiar with virtual machines. So that's how the VM piece works. Oh, and then this yellow kind of arrows that you see. Just launching Linux binaries isn't very useful if you can't provide input or get the output. We use some sockets. Linux has vsock. Microsoft calls it HVSocket. We have some socket APIs to be able to get input into and out of this virtual machine environment, and it's all just seamless. It just will work under the covers for you. So what are the actual pieces of WSL? When you launch a distribution, how does that work? What are the various parts?
We promised you a deep dive. This is the deep dive section.
It's about to get deep. I don't know. Medium dive, maybe. We'll see. So the first thing, the entry point to WSL, WSL.exe. So this is used for, we showed you listing distributions, we showed you launching distributions. It's kind of our Swiss Army knife for interacting with the subsystem. This calls into the LXSS manager service. That is the WSL service that keeps track of what distributions are installed, what distributions are running, things like that. And then, so we're launching WSL. Let's assume we're running Alpine or something. To create this lightweight VM, we then call into the host compute service. That is I alluded to the virtualization technology that makes this possible. Host compute service, host network service are two pieces of that. So this creates this lightweight VM with the Linux kernel that we are shipping in box. And then this starts running. So this is the virtual machine with the Linux kernel running. We then map in your distribution's file system, so that ext4 formatted VHD. We run our init process, just like we would in regular WSL, and then we launch the app that you wanted to launch. So in this case, your user's shell, bash. And then I mentioned this is running, that's great. I need to know what bash is telling me, or else it's not very useful. We then set up some relays to relay from standard in on the Windows side to bash in the Linux side. So we read from standard in, send it over a socket. Socket is, you read from that socket in the guest, and then that is the standard in for bash. So that's pretty neat. And then, like I mentioned, this virtual machine only runs while you have Linux applications running. If you were to kill bash.exe, or if you were to kill WSL.exe, this virtual machine would go away after a little bit of a quiescent state and then start fresh. So let's talk about some of those integration pieces that I mentioned. So with WSL1, accessing host files was pretty trivial because you're on the same machine. You're not, there's no boundary there. There's a lot of implementation to get the right Linux semantics on top of NTFS and the file manager and the files, but they are on the same machine. This is different in WSL2. So what we use for this is we use the 9P protocol. It's a file server protocol that is used elsewhere in the Windows container stack. And this allows you, we mount drives using this protocol, and the server runs in the Windows host. So when you go to your mount C directory, this is how you get to your C drive on Windows. This is this ends up going through the Linux kernel. Linux kernel is the Plan 9 client in this case. Talks to the Plan 9 server running on the host, and then that serves the files into the guest. So this works really well. It's pretty neat. If you didn't know this was running a file server, you probably wouldn't notice. And so that's pretty cool. So let's talk about a special case of accessing Windows files, accessing a Windows executable. So in this slide, you'll notice cmd.exe is now that Windows file that we're wondering about. So to find this file, same way that would have happened before, we will go through the Plan 9 server and find cmd.exe, and then if you're familiar with WSL, we use a piece of Linux functionality called bin format, which is you're able to associate file executable types with the Linux kernel that can be handled by user mode. It's pretty cool. And we use that for Windows PE images. So we will then exec our bin format interpreter. That talks back to the host, and then we launch the real cmd.exe. And similarly, relay input back and forth, and it's just really seamless. So I'll show you what that looks like in a minute. And then if you want to access the files in your Linux environment, how does that work? Like, it's an ext4 drive. How can I get to this from Windows? That seems like a problem. So the way we've done this is the same way, but in the opposite direction. We use the same Plan 9 server, this time built for Linux. Same source code with some, some platform-specific layer, but this runs in the guest. This part will be available in 19H1. It's not exclusive to WSL2. WSL1 also uses this functionality to be able to view your Linux files. So this is pretty neat, and it's been a cool project to work on. To be building something out of the Windows source for both Linux and Windows has been kind of neat. So let's show you what that looks like. So we'll jump to another demo. We've got our shell up again. Cool. And then, okay, let's launch Alpine again. Actually, maybe Ubuntu.
Yeah,
let's do Ubuntu, because there's some more stuff there. So let's show you what I just went over in the last couple slides. So we just started and we're already in the C drive, right? So that's cool. Let's make some files on the C drive. And since we're doing a live demo, I'm just going to go into Craig's user directory and see what I can find. It's probably not a good idea to let a dev access your machine like this, but there we are. Okay, so cool. So we have on our desktop, I'll make sure you guys can see it. This is the folder open, but here it is, demo. So we've got a demo folder on our desktop. And then I will create a file from inside of the Linux virtual environment. Just dump. I don't know your password, so I won't type sudo. So that's fine. Anyway, you'll take my word for it. This is WSL2. So let's just create a file. Very CS1000. Create a foo file. Cool. So you see it showed up in that folder on Windows. And then let's edit this with everybody's favorite editor, VS Code. It's my favorite editor. We'll add some text. Is that the year? I sometimes forget. Yeah, I think it is. Okay, cool. Go back to our shell. And then we will, let's open it in VI, everybody else's favorite editor. There you go. So we've created a file from WSL, changed it on Windows, accessed it again from WSL to, and really seamless. It's really, it's a pretty cool experience. And I'll show off interop as well. So cmd.exe is kind of what I showed on the slides. Let me move this so you can see a little bit better. Cool. So this is us launching the Windows version, the Windows cmd.exe. And there you go. So that's now running on the host, and all the input and output is being relayed to the guest. And you can do dir, and you can see that same file. And then you're able to use from this environment any kind of Windows app that you want, including graphical apps. There you go. So that's pretty cool, and that's that works in WSL1, but it also works in WSL2. And so let's go the other way. Let's view our Linux file system. So bring up Explorer, and we'll go to. I lost the mouse. There it is. Cool. So we've got. This is the functionality that will be available in 19H1 to WSL1 as well. We will see our Linux distributions. So it looks like we've got 3 running right now. Let's go into Ubuntu again. And so here is the Linux root file system of Ubuntu, and we can do some really funny things. Let's go into like Etsy. Etsy has some kind of system-y files in it. Let's maybe look at something that actually has content. Might be nice. Like resolve.conf might be nice.
And what's awesome is any Windows app can access these files.
Right.
You can do it through command line at //WSL $ your distro name, and so it's not just File Explorer, like VS Code can access these all from your Linux root file system.
Right, right. So you'll see this path at the top. That's how you get to these things. And so let's open this. You'll see, here's a file that's purely a Linux file, and accessing it through a Windows editor. So that's pretty neat. Let's get crazy though. So let's go to like procfs. So procfs is one of those virtual file systems that I mentioned. Let's just open procfs in, I don't know, let's see, PowerShell. Let's do PowerShell.
All right.
So cool. So we'll launch PowerShell, and then you'll notice the path. This has automatically brought us into that directory, and now we are in procfs in that Linux utility VM. So that's pretty neat.
Awesome.
And these 0 file sizes might jump out at you. That's actually Linux reports 0 file size for procfs files. So we're doing the right thing. That's not wrong. It's a Linux thing. So there you go. Cool. Was there anything else we wanted to show in that one? Cool. Thanks, Craig. Yeah. Let's do questions at the end, if you don't mind. Cool. Sure. We'll have some time for Q&A. We're starting to. I guess I didn't go to the demo slide.
That's
cool.
Okay.
So let's do that. I'll add a couple more pieces to the architecture diagram. We have this shows both the Plan 9 server in both directions for accessing Windows files, for accessing Linux files. You'll also notice inside that virtual machine we have Ubuntu and we have Debian. So we run one Linux utility VM per user. So if you have multiple distributions that are running WSL2, you will have one VM, and we use Linux namespace container APIs to accomplish this. And the goal there is just we want this Linux VM to be really lightweight. And if you run 4 distributions, we don't want to have to create 4 virtual machines. So they're isolated from each other, but they are privileged containers. So enterprising users will be able to break out of that. But it's all your files, so you're not really risking anything doing that. So if you've been using WSL since 2016, when we announced it build, that was quite fun. You'll probably know of some features that we've added along the way. Accessing Windows files, we showed you that. Interop, we just showed off that. WSL.conf is a really cool utility to tweak settings of the distribution. WSL path allows you to translate between Windows and Linux file system styles, forward slashes, backslashes, that sort of thing. WSL env, you can share environment variables. We have background task support. If you launch a daemon process and close your bash window, we will keep your instance, or in this case, your virtual machine running until that process exits. So those were all really cool features that kind of came from our suggestions from our GitHub community. And I'm really happy to announce that all of that stuff just continues to work with WSL2. And if you find something that you were using in WSL1 that doesn't work, please file a GitHub issue, because it's something that we should certainly fix. We want this to be really seamless and for you to not have to think about it. And anything you were doing yesterday with WSL1, you'll be able to do in June whenever we release to insiders with WSL2. So that's our goal. So anyway, thank you. I'm going to kick it back to Craig to kind of wrap stuff up. Thanks.
So our roadmap. So what are we going to be working on next? What can you expect with WSL in the future? As Ben just said, our top priority is to make WSL2 feel exactly the same as WSL1. That's based off your awesome user feedback, so we're looking forward to hearing from you when you start using WSL2. On top of that, we have not forgotten top customer asks from our users. There's still things that we need to address inside of WSL. We're really aware of those, and we want to keep working towards them.
And this is a great opportunity. If you look at our user voice, there are a lot of these issues that go away. Anything that has to do with, this system call doesn't work, I want to use Fuse, all of these are gone, so now we can focus on, the really cool scenario asks.
Exactly. And the last one is improving integration. And so we're always wanting to make a more integrated environment between Linux and Windows. And this is not something that's just done on the WSL team. So I want to really quickly show one last demo before we stop. If you have not seen VS Code Remote, you need to check it out. It is awesome. It is a way for you to run Visual Studio Code where only the UI is running in Windows and everything else is running in Linux in the back end.
This is brand new. They announced this on Thursday or Friday?
Last Thursday.
Yeah,
so it's brand new. It's available on Visual Studio Code Insiders. So let's take a look at what that is. So it'll show up like this. You can install it right away. You'll open it up, and you will notice that at the bottom here, let's do this. There we go. At the bottom here, it's opening remote. And so it actually will be opening a remote session, and it says WSL right on the bottom left corner. And what is awesome about that is now everything in the back end is running inside of the Windows subsystem for Linux. So all of your environment variables, all of your tools, all of your extensions are all Linux-based. And so obviously you should not take just my word for that. We're going to do a live demo. I'm debugging this Go language code directly inside of Linux. And to prove it, I check out the OS, and it's running as a Linux process. And this is all done directly in VS Code. My terminal is the bash shell. And I can go and stop this. And let's open up another one. So if I go here, I click on the WSL logo on the WSL text on the bottom left. I can go remote WSL new window. And I can open up a project just like I would in regular VS Code. But you'll notice my folder structure is my Linux system. So it's in my Ubuntu distro. And so I can go in here, and I have some build demos. Spell it. And I have a Python demo in here. And so I can go and open this folder. Let's close Go language. And open up Python. And this is the exact same experience as before. It's all running directly with Linux on the back end. And I can run this and debug this inside of Python directly as I would exactly on a Linux machine.
Right.
So if you're doing any kind of development and you're using WSL and you're using VS Code, VS Code Remote is a really amazing way and really powerful way to start using your Linux environment as a full-featured development environment.
Right.
So you can see running Linux as my OS for this process.
Yeah. And VS Code Remote is available today, and it works on WSL, but he's showing you it also works in WSL2. So that has all sorts of additional benefits with the compat.
So the stuff you're really interested in, how do I start using this? When can we get this on our machines? It's going to be available in the Windows 10 Insiders program on the Insiders Fast Ring. It will be available by the end of June 2019. You can register using that link there. Don't worry, we also put it on this page right at the bottom. So thank you for coming to our talk. Thank you so much. My name is Craig Lowen. You can find me on Twitter at Craig A. Lowen.
Yeah, and I'm Ben Hillis. That's my Twitter account.
And we've left a ton of resources for you up here. Our command line blog is where you can get all the news of WSL. GitHub is for issues. A Learn WSL page to learn details about WSL implementation. Our documentation page. Our user voice page where you can ask for more features. And lastly, the Windows Insiders link. Thank you so much for coming here today.
Yeah, thank you. So we have, Great job, man. So it looks like we have about 10 minutes for some Q&A. If you have any questions for Craig or I, if you do have a question, we have a microphone here. So please make a line or go up. This is being recorded. We want people to be able to hear the questions on the recording.
And I've left up the feedback if you'd like to give feedback.
Great. Cool. Thanks. Hey.
Hello. So I have a Windows on ARM laptop that's running a Snapdragon 835.
So do I.
Am I going to be able to run WSL2 on that?
So a lot of the ARM64 chips that have been released so far don't have virtualization. Do you know if that one is virtualization enabled?
I'm not completely sure I am.
So if it has the VTX support, then yeah, it'll work. We're working on, currently we build that kernel for x86. We're going to build it for ARM64, but it's in progress. So, but yeah, eventually you'll be able to use WSL2 on ARM64.
Okay, thank you.
Yeah, and thanks for using ARM64, it's great.
And to jump really quickly on that as well,
Sure.
This is a really common question that we've gotten a lot since the announces. What's happening with WSL1? Are we still continuing that? WSL1 and WSL2 run side by side.
Right.
We're going to base our future plans on user feedback. And so in your case, for running it on ARM laptop, WSL1 will still work.
Great.
Hi. You talked a little bit about Docker support on WSL. Now, there's a different solution for Windows on Docker versus Linux, Docker for Linux.
Right.
Do you talk a little bit about what the differences are and what the compatibility sets will be and what limitations mean?
Sure, yeah. Do you want me to take this one?
Yeah.
Cool. Yeah, so Docker for Windows the product is great. It's a great way to run Linux containers on Windows. The way that works under the covers is they create a virtual machine, like a traditional virtual machine, and they run Docker daemon in that VM, connect to it from the Windows host, and that's when you launch a container, you go into the guest and launch launch that way. So that's Docker for Windows today. Docker on WSL, like if you were to run the Docker daemon in WSL, you could run the one that you would launch in your WSL shell, start the service like Craig showed you, and then you could connect to it from Docker client on the Windows host, or you could use the Docker client inside of your Linux shell as well. Does that answer kind of what you were saying?
Yeah, I'm just curious if there's any limitations I should be aware of.
There should not be. I mean, Docker is one of our, it's really high on the list of things that we want to work because we know it's such a powerful and important tool for developers and ops and all sorts of stuff. So yeah, I mean, if you find that Docker is not working well on WSL2, it's certainly something that we need to address. But in my experience, it works great because it's the real Linux kernel, so it should behave just like on native Linux. So. Great.
Awesome. Thank you.
Yeah. Thank you.
Hi. Are there any plans to support passing through hardware to WSL? So think for running like video cards for running things like CUDA or.
Yeah, sure. I'll let you.
Oh yes. CUDA is and GPU access is a very highly requested. It's our #1 issue on user voice, so we're really aware of it. And it's on the radar. And the great part about the new architecture is it allows us a better platform to help deliver these changes. Right. So as Ben mentioned, there's like a giant blinking red light on our user voice and issues page of, hey, this system call doesn't work, or hey, we're fixing this. And we basically fixed that, resolved a lot of that issues, and now we can focus on some of those other exciting features, like, for example, taking a look at the possibility of GPU support, sound card, other hardware access.
Right.
Thank you.
Thank you.
So anytime I turn on Hyper-V on Windows, I usually lose the ability to run VirtualBox or Intel debugging for Android or accelerated debugging. Is that gonna, now that WSL is running with Hyper-V, is that gonna happen whenever I turn on WSL2 or?
Right. So I'll say yes. We do use the Hyper-V hypervisor to run this, but we are. You may be familiar with, so Android, you mentioned the Android emulator. They actually recently moved over to using a set of APIs that we provide for them to use our hypervisor directly. So actually, you can run the Android emulator with the Hyper-V hypervisor installed. Like that works today. And we're working with other virtualization platforms that to use those APIs as well. So I can't commit to their timelines or anything, but we do have a set of APIs that are available for external people to use our hypervisor, and we think that's a really good opportunity to do that. But yeah, your question is correct. Yeah.
Okay. Thank you.
Thank you.
Hi. So I used gvim to edit files to WSL.
Okay.
And I noticed that it doesn't always notice immediately when the file changes from some other direction.
Okay.
I'm guessing that has to do with missing Inotify support or something like that.
Okay.
So is that going to magically appear in WSL2?
Yeah, so Inotify is something, so specifically accessing Windows files, is that what you're talking about? Yeah, so Inotify, I believe we still need to plumb like file notification support into our Plan 9 servers, but yeah, it's on our backlog. It's something that we know people use and want to use. You will have much better Inotify support in the Linux file system. You'll have, because you're running the real Linux kernel in that case. So yeah.
Okay, thank you.
Thank you. I think we have, no, we've got 4 minutes.
Yeah, we got time.
We got lots of time. I thought it was 40 seconds.
Hey guys, where are you at with bringing this to the Windows Server platform?
Yeah, so WSL is on server as of, was it 2017? I can't remember.
So
Yeah,
yes,
but
2018 for sure.
Right.
And WSL2 is also available on all SKUs for that WSL1 supports. So that includes Windows 10 Home,
right.
Which is also a common question, and will also be
Right.
available on server.
Yeah.
Excellent, thank you.
Yeah.
Thank you.
I was wondering if there was any effort to merge the permissions models between Windows files and Linux files. For example, sharing a private SSH key between WSL and Windows.
Right. I mean, it's a great question, and it's really a hard problem. If you're familiar with any SMB or kind of file servers that kind of work in both Linux and Windows environments, you're probably aware that some of the mappings are are cumbersome, and it's not, it is a generically very, very difficult problem. But we think that we largely, by leveraging Plan 9 and doing the, basically when you're accessing files in one way, the permission model is that, it's the Linux version if it's the Linux file, if it's the Windows version if it's the Windows file. We think that's a good, using our Plan 9 server to do that, I think is going to be work pretty well. But yeah, we thought about this a lot, and my file system guy's in the back, and we spent a lot of time trying to reconcile these two kind of very different worlds. And I think any mapping that we would have had like a lot of issues. And I'm really happy with what we ended up with WSL1 and DriveFS, and I think it's really great. It's not perfect, but I don't know if a perfect solution exists, really.
Right. And a lot of the time, people build solutions on top of the WSL architecture. For example, the Penguin team is here, and they built some awesome solutions targeted to WSL. And some of the blog posts you mentioned, SSH keys, people make symbolic links, right, between their .ssh folder over to their Windows folder.
Yeah, that's worked very well for people.
Yeah, so I would consider some solutions might be building on top of WSL as well.
Okay, cool. Thank you.
Thanks.
The demos showed how you can reuse the file system and really good sharing between the Linux system and Windows. Huh? What about for networking?
Yeah, so networking is an area. On Craig's slide, he mentioned improving integration. Networking is an area that we are working on making a much better story. Currently with WSL2, it's a lightweight VM, but it's still a VM. It will have a different IP address from the host. We're working on some really cool things to I think it'll be kind of phases, right? So phase 1, different IP address, but much better networking support, much faster, but different IP address. Phase 2, there's some interesting ideas that my manager and I have, and the rest of the team have about mapping localhost in the guest to localhost on the host. So some clever ways to make localhost seamless, like be able to connect to localhost from Windows, and all that just works. So we have some cool ideas on how to make that work. And then long term, we're hoping that we can get to a world where the guest is able to share the IP address and port namespace, and that's a long tail of work. But I think it's a really interesting piece. I think there's other interesting scenarios for that could use that. So I think that would be valuable work outside of just WSL. So that's kind of don't have a roadmap of any of that stuff, but networking is certainly an area where you will see pros and cons between 1 and 2. But I think a lot of the pros, in my opinion, from using it for a while, really outweigh some of the cons. You may have to do things slightly differently, but.
And to be clear, that's for initial preview builds.
Right.
WSL2 will behave slightly more like a remote machine. It's something that we'll fix over time as we release to insiders, and that's based off your feedback as well. If we hear, hey, we really want to fix this, that's how we prioritize the work that we do. And then on top of that. Yeah, that's basically it, actually.
Cool.
Thank you.